Hello students, this is Maisum Hayati and welcome to A-Level Mathematics Online. In this video, we are going to discuss differentiation. So before formally starting differentiation, we need to understand that there are four different type of functions for your course, and those are logarithmic, arithmetic, trigonometric and exponential. And for AS Mathematics, we are only going to cover algebraic functions. The rest of these functions, trigonometric, exponential and logarithmic, rest of these functions are for A2 mathematics, that is P3. So only algebraic function is part of the P1 course, and the rest of these functions, the differentiation of rest of these functions are part of P3. So we are going to start with algebraic functions. So let's say we have x. So this is basically an algebraic function. It has a power which is 1, a variable and a numeric power is basically an algebraic function. So we can have some more variables. We can have y to the power 3, we can have p to the power 100, we can have q to the power half, and we can have 1 over r. So these all are simple algebraic functions, and you need to identify these functions as simple algebraic functions so you can apply the rule of differentiation to these functions. So first of all, you need to identify these functions as simple algebraic functions, and then after that you need to write something, and that is, if you are going to differentiate this function, so you need to write d over d, and what variable is this? This is x, so you need to write here x and put this function into bracket. For example, you need to differentiate y cube, so you need to put a d over d y here and make a bracket. P to the power 100, d over dp, d over dq, and d over dr. So whatever variable is present in the function, you need to write that variable, that particular variable here in the denominator. So this basically means you are going to derivate. Differentiation or derivation is basically the same thing. So you are going to derivate this function with respect to the same variable, d over dx, or differentiation of this function. It all means the same. So now that you have understood the rule, we are going to derivate these functions. So our first example was x to the power 1. So how we are going to differentiate this? It is quite simple, that you need to bring this power in the coefficient, you need to multiply the power with the function, so it will become like 1 x to the power 1, and then you need to subtract 1 from the power, and you will get your answer for simple algebraic function. So it will become 1 x to the power 0, and anything to the power 0 is 1, so your answer is 1. Can we generalize this rule that if you have a variable, it can be x, it can be p, it can be q, it can be r, it can be any variable. If you have a variable and you have a power 1 to it, and you are going to differentiate that function, so you will always get a 1. You will always get your answer as 1. So this was a rule. Now we are going to differentiate the second type of function. For example, we have x cube. and we are going to differentiate this. So you need to bring this power, you need to multiply it here. It will become 3x, and then you write this power again, 3, subtract a 1 from it, and you are going to get your answer, 3x square. Some more examples. So it was quite easy. Now we are going to deal with some different examples. So we have root x, which is also x to the power half. And how you are going to differentiate this? You need to bring this power down. It will become half x, and then you need to subtract 1 from it. So it will become half x to the power minus half. For simplicity, you can bring this x in denominator to make the power positive. So it will become half root x. So the differentiation of square root x was 1 over 2 root x. Let us take some more examples. For example, we have 1 over x. So we need to write d over dx. I actually forgot to write d over dx in the rest of these functions. You need to follow the rules because it is important to make the examiner understand that you are going to differentiate the function. So d over dx of 1 over x will be, you need to first bring this x in denominator into numerator. So the power of x in denominator is 1. If you will bring this x into numerator, it will become d over dx of x to the power minus 1. And now the rule is the same. Bring this power to the left. So it will become minus 1 x, and then subtract a 1 from it, minus 1 from the power actually. So this will become minus 1 x to the power minus 2. So the answer will be minus x to the power minus 2. And if you want to make the power positive, you can write it like minus 1 over x square. So the differentiation of 1 over x was minus 1 over x square. These were some examples for differentiation of simple algebraic functions. We can take some more examples. Let us have an example, 5x square plus 2x over 3x. And we are going to differentiate this. So we need to write d over dx because the variable involved in this function is x. So you need to write here x. D over dx of 5x square plus 2x over 3x. So this is a complicated example. So how we are going to deal this? First of all, you need to simplify this function as 5x square over 3x plus 2x over 3x. Now we are going to simplify this. We can cancel this x from this and these x, and this will become 5 over 3x plus 2 over 3. And now we are going to differentiate it. So we need to write d over dx 5 over 3x plus d over dx of 2 over 3. Now you can have one question here that, sir, we do not have any variable involved in this. So why are we writing x here? So you need to understand that this 2 over 3 came from 2x over 3x. So initially we had a variable x there. So you can, it doesn't matter what variable you write for the constant, because after the result it will become much clearer to you that why it is not important to why the variable of denominator is not important actually. We are going to differentiate it. So before differentiating 5 over 3x, we are going to differentiate 2 over 3. And then we are going to differentiate 5 over 3x. So I am going to make a point here, and that point is quite important, and this will make your calculations faster. So we are going to differentiate 2 over 3 first. So let's say we have 2 over 3 like this, and we do not have any variable, so we can assume that we have x to the power 0, because x to the power 0 is same as 1. So we are just assuming x to the power 0 here. It won't make a difference. Now we are going to bring this 0. We are going to multiply this 0 by 2 over 3. So 2 over 3 multiplied by 0. This is basically all the rules that I have told you. I'm actually following all the rules here. So we are going to multiply this 0 by 2 over 3 and then write x and subtract a 1 from the power. So this is going to make no difference because we are going to multiply 0 with everything. The final answer will be 0. So this makes us understand that the differentiation of any constant is always 0. It always will be 0. So because differentiation means change, and a constant never changes, so it always will be 0. There is no change in a constant. So the differentiation of this constant is 0. Now we are going to deal 5 over 3x. For 5 over 3x, we are going to ignore the coefficient 5 over 3. We are going to ignore that because it won't change. So we are actually interested in x only. So we are actually interested in x only. Because 5 over 3 cannot change, so we are taking that out and only differentiating the function x. So d over dx of x. And I told you that any variable with power 1, the differentiation of any variable with power 1 is always equal to 1. So we have answer 5 over 3. The differentiation of 5 over 3x was 5 over 3. So this is how you differentiate, guys. These were simple algebraic functions. Now we are going to discuss some more examples. We are going to do some more examples for simple algebraic function. Okay guys, now we are going to do some more questions for simple algebraic functions. Let's say we have a function 1 over root x, and we are going to differentiate this function. So we need to write d over dx because the variable involved in this function is x. So we are going to differentiate 1 over root x. So first of all, we need to bring this root x in the numerator. So we are going to simplify this function first before differentiating, so it will be easier for us to differentiate. So 1 over root x literally means 1 over x to the power 1 upon 2. And then we can bring this x to the power 1 over 2 into the numerator, and that would become x to the power minus 1 over 2. And then we can differentiate this x to the power minus 1 over 2. So x to the power minus over 2 d over dx, it will be, so basically you need to multiply this minus 1 over 2 with the function. That would become minus 1 over 2 x minus 1 over 2, write the power again, and you need to subtract a 1 from the power, and this would become minus 1 over 2 x to the power minus 3 over 2. So the differentiation of 1 over root x was minus half into x to the power minus 3 over 2. This answer is complete, but you can do one thing. You can bring this x to the power 3 over 2. This you can bring this part into the denominator, and this looks a pretty answer. So we have done a differentiation of 1 over root x. Now we are going to solve some more examples, and the second example we have is 3x square minus 8 root x over 3x, and we are going to differentiate this. First of all, we need to write d over dx. This was the first rule, and then we need to simplify the function a bit. See, we can distribute this d over dx to each part of the function like this, d over dx to 8 over 3 root x over x. So now the differentiation of 3x square, you are not interested in the coefficient because the differentiation of any constant is 0, so it won't affect the 3 that is being multiplied by x square. So you can just write 3 as it is, and then you can differentiate the x square. So for x square, you need to bring this power, this 2, you need to multiply this power by x, so this would become 2x, and then you need to subtract 1 from the power. So this is the differentiation of 3x square. And now we are going to deal the second part of the function, which is 8 root x over 3x. Since 8 over 3 is a constant, it won't affect, the differentiation won't affect the constant, and then you need to simplify this function first. Root x over x. So root x over x literally means x to the power half over x to the power 1. And using the rule of indices, we can write x, because the base is same, so we can, and both the functions are dividing, so we can subtract the power 1 over 2, x to the power 1 over 2 minus 1. This would become x to the power minus 1 over 2. And the differentiation of x to the power minus 1 over 2 was minus half into x to the power 3 over 2. So we can write that part, I'm skipping it, we can write minus 1 over 2 x to the power 3 over 2. So guys, this was the differentiation of 3x square minus 8 over 3 root x over x. We can simplify this a bit. This would become 6x and plus this would cancel out 4 over 3. It became a triangle, 4 over 3, and this would be x 3 over 2. So 6x plus 4 over 3 x to the power 3 over 2. Just by the way, this x is in denominator. So this is the answer, final answer to differentiation. This was another question, and in the next video we are going to do composite algebraic functions. So stay tuned. Thank you.